Recently, I received a few comments from curious viewers wondering why I had not yet made a video about the DART mission that's due to take off in a few hours from the time of this recording. Well, I actually did make a video about this asteroid defense system and a lot of its drawbacks, including the fact that an ESA probe called Hera was supposed to arrive at this asteroid before DART and failed to do so because of a lack of funding. There are a lot of holes in our asteroid defense. As a matter of fact, we don't have any asteroid defense at all. That made me angry then, and it makes me angry now. Not a lot of you have seen this video, so I have decided to re-release it. So get ready to turn back your time to 10 months ago for a very special episode of The Angry Astronaut. In 2014, the planet Mars had a close encounter with a visitor from the Oort cloud known to us as the comet Siding Spring, which we had only detected the year before. Now, two things made this encounter extremely disturbing. Number one, that we only detected this comet 1 year before the close encounter occurred, which would not be nearly enough time to stop it, assuming that it was on a collision course with Earth. And secondly, that it passed at a distance of less than 1/3 of the distance from the Earth to the Moon. Now, given that Earth's gravitational pull is triple that of Mars, it might have pulled this comet a little bit closer, making a close encounter with the Earth, had it occurred back in 2014, both spectacular and utterly terrifying. Now, since this close encounter did not happen with Earth, but rather with Mars, only the Curiosity rover got a terrifying experience from this close encounter. But nevertheless, this particular incident should teach us a hell of a lot about the potential danger of approaching objects that we are not aware of. In a time that NASA has recently announced that we have identified 99% of the objects that could create an extinction-level event on this planet, we are not taking into account objects that come from outside the inner solar system, and they come on a disturbingly regular basis, and we don't detect them until it's far too late. Now, had Siding Spring collided with the Earth, it probably would not have created an extinction-level event. However, it still would have been an incredible explosion and unbelievably devastating. We're talking in the vicinity of about 100,000 megatons. Not 100 megatons, 100,000 megatons. Now, an explosion of this magnitude would have a blast radius of about 150 kilometers, and if it hit an ocean, which it would have about a 70% chance of doing, it would create global tsunamis and devastation unlike anything we have seen in recorded history. Now, as far as what an explosion of this magnitude would do to the weather, we do have a historical record. When Mount Tambora erupted in 1815, it created a year without summer in 1816 and inspired the poet Lord Byron to write, "The world was void, the populous and powerful was a lump. Seasonless, herbless, treeless, manless, lifeless, and the clouds vanished. Darkness had no need of aid from them. She was the universe." Now, even though a comet like Siding Spring would create a cataclysm like what Lord Byron experienced, except many times worse given the far larger population that we have in our 21st century compared to his day, we are doing surprisingly little to stop this from happening, in spite of the fact that we know for certain that something like this, or perhaps even worse, is going to be happening in our future, just a tick on the geological clock. And the fact that we are doing so little makes me angrier than just about anything I've ever discussed on this channel. Get ready for a special episode, a 40,000 subscriber episode of The Angry Astronaut. Welcome to Meteor Crater, Arizona. Unfortunately, as a result of some audio issues and also the fact that I was surrounded by tourists that didn't have a hell of a lot of respect for YouTubers, I'm having to record the audio for this on the following day. That being the case, however, this was a remarkable experience to say the least, and I'm hoping you're getting a little bit of the scale of this place. This crater is utterly gigantic. The distance from where I was standing to the other rim of the crater is about 1,200 meters, and the depth of the crater is about 170 meters, although it used to be deeper. Erosion over the last 50,000 years has caused material to accumulate at the bottom of the crater, making it more shallow than it used to be in the past. The iron asteroid that created this crater was a pebble compared to the Siding Springs comet that we were just talking about, a mere 45 meters in diameter, and yet it still created a 20 megaton explosion and this colossal crater that you're looking at right now. And by the way, if you think that this is stock footage of some kind, well, hello everybody, here I am. Yes, that's my hand. So let's keep talking, shall we? The scale of this crater is difficult to describe unless you're actually there, but here's one way to describe it. See that rock way out there on the rim that I photographed? That's what that rock looked like from my perspective when I took this photograph. And this is what that rock looks like when you photograph it close up. And just for a sense of scale, let me show you what a full-size adult looks like when compared to that particular rock that was tossed out like a pebble by the force of the explosion. Now, this little 45-meter asteroid, traveling at about 13 kilometers per second, displaced over 300 million metric tons of rock and earth when it impacted 50,000 years ago. And I got to see the crater from a variety of different perspectives, although on the tour they didn't let me set up my tripod or give me enough time for that, so some of the images are kind of shaky. And yes, I was obsessed with this rock. Now, Meteor Crater, Arizona remains the best preserved and first identified meteorite crater on the planet. And however, it was not identified solidly as such until the 1960s. This whole issue was fiercely debated, and as recently as the early 20th century, the U.S. Geologic Survey believed that this was the result of volcanic activity. Until, of course, they started discovering rocks like this one, which is the largest remaining fragment of the iron asteroid. And by the way, this thing is not very large at all, about the size of a child, and yet incredibly heavy and worth millions of dollars. But the fact that after years of mining and searching, the Barringer family was only able to uncover a fragment this large, and a lot of others that are significantly smaller, such as this one, which was stolen from the facility and later returned, is an incredible testament to the explosive force of an asteroid impact. The vast majority of the 45-meter hunk of iron that fell here 50,000 years ago was either vaporized or pulverized by the force of the blast, and traces of its existence can be found just about anywhere along the rim. As a matter of fact, if you drop a magnet in a random spot somewhere around the crater or somewhere in the vicinity of the crater, you will invariably pick up magnetic pebbles and other tiny bits of the asteroid. 50,000 years after the collision, you can easily find remnants of its existence. But even though visiting this crater was a magnificent experience, at the same time I found it pretty disturbing, because objects of this size are extremely difficult to detect. As a matter of fact, we've detected a very small percentage of the ones that are currently flying about in near-Earth orbit. And as you can see, any one of these objects can create an explosion far more powerful than most of the nuclear weapons in the United States arsenal. And these sorts of things happen far more often than we might think. In 1908, the so-called Tunguska event flattened over 2,000 square kilometers of forest land in the middle of Siberia. Fortunately, because it hit a completely unpopulated area, nobody was killed, as far as we know. Now, because of the Russian Civil War and the general state of chaos in Russia during that time, the Soviet Union did not send out a scientific expedition until the 1920s, but the actual cause of the event remains a source of debate to this day. But the best idea is that a stony asteroid or a comet airbursted a couple of miles in the atmosphere, which increased the area of damage without digging a huge crater. Regardless of the cause, the visible devastation caused by this event is something that's a little difficult to describe unless you look at pictures made from the time. And by the way, this is more than a decade after the explosion. Hundreds and hundreds of square miles of flattened trees radiating out in all directions from ground zero. One can only guess what the devastation would have been like had this hit a populated area. And given what happened in Russia, ironically, in 2013, it would appear that these things hit us more often than we used to think. And have a look at the census of near-Earth objects and the number of asteroids that we have yet to locate, especially the smaller ones, the ones between 100 and 300 meters or even smaller than that. And keep in mind, the Tunguska event was probably caused by a meteor in the smaller category on the bottom. Now, suppose there were a nation-state on Earth that would refuse to negotiate with us under any circumstances, and we knew that they were going to drop a nuclear bomb somewhere on the planet in the next century or so. What do you suppose we would probably do about that? Well, we'd probably commit billions of dollars and thousands of troops to stopping them. But what have we committed to asteroid defense? Well, next to nothing. The European Space Agency intended to put up a space telescope specifically designed to detect near-Earth objects, including dangerous asteroids, but predictably that was canceled, as was the asteroid redirect mission, leaving us with one mission in 2021. And, predictably, even that mission has been scaled back tremendously. Originally, this was supposed to be a combined mission between the ESA and NASA. The ESA was going to dispatch a probe called AIM, and this particular probe was going to study a binary asteroid system, and it was going to be followed up by a NASA mission called DART. Now, the purpose of the AIM probe was to provide targeting directions for the U.S. DART mission, studying the smaller asteroid, which was called Didymos, providing as much information as possible, including high-res mapping for the DART probe, which is little more than a 500-kilogram kinetic impactor, designed to hit the smaller asteroid at a speed of about 6 kilometers per second. Now, once AIM had gathered as much pre-impact data as possible, then DART would make its approach and impact, as I said, at about 6 kilometers per second. And this would allow AIM to examine the asteroid post-impact to determine what sort of effect the impactor had had. Now, since this is a binary system with a smaller asteroid orbiting a larger one, it would provide us with a perfect opportunity to see how much an impactor would change the orbit, and the AIM probe would be able to determine this with very, very great precision. But, as I said, AIM was canceled, so all we have left is DART. Now, ground observatories will probably be able to get similar information, at least in terms of how much the orbit changes, but what they won't be able to gather is how much of a change was made to the asteroid itself, whether or not the impactor might fragment the asteroid apart, which could theoretically make for a bigger problem in the future. So this really is only half a mission, which will be partially completed, at least in theory, when the Hera probe from the ESA arrives later on. But nevertheless, this is just one example of how little of a sense of urgency we have when it comes to this really substantial danger to human civilization. And incidentally, we're far from certain if using kinetic impactors is the best way to handle this problem anyway. Another solution that's been proposed is something called a gravity tractor, which simply uses the gravity generated by a spacecraft to divert a small asteroid. Now granted, a spacecraft doesn't have much gravity, but it doesn't need to have enough to divert the course of a very small asteroid by the small enough margin necessary to miss the planet. Now personally, my favorite solution is to use orbiting laser arrays to deflect an incoming asteroid. Granted, photons don't provide a lot of deflection, but if you have a lot of them being generated by quite a few laser arrays in the megawatt range at least, then it provides enough concentrated fire to divert the course of an asteroid just by the force of the photons alone. And in the case of a comet, it provides even more deflection because it heats the surface, providing cometary outgassing, which will divert a comet even further. But the reason I like this solution the most is not because I think lasers are cool, but rather they serve a lot of other purposes besides just deflecting asteroids and comets. For example, they can be used to power light sails, such as proposed in the Breakthrough Starshot initiative. And just to quickly review this initiative, the proposal is to use extremely powerful laser arrays to propel small light sails to speeds of up to 20% that of light, and then to dispatch these light sails on a journey to Proxima Centauri and its neighboring planet. And in addition to providing us with interstellar travel and asteroid protection, this system could also provide the Earth with an enormous amount of power, because the solar panels necessary to power a laser array of this magnitude could also be used to power stations on the surface of the planet, using the same lasers in theory, although these lasers could be weaponized. Therefore, I would recommend, if we are going to build something like this, to make it an international project. And by international, I mean giving every participating country, foremost of which would probably be the members of the UN Security Council, the ability to shut this system down should someone get a bright idea to use it against a target on Earth. But imagine all of the different uses that a system like this could be put towards, not least of which defending the human race from possible extinction. But what could possibly deploy something so vast to near-Earth orbit? Well, I think you just guessed it, the Starship, a vessel that's capable of deploying 100 tons worth of payload into near-Earth orbit with every launch. Because no matter what system we end up using, it's going to be far more effective if it's already in orbit and ready to be deployed against an incoming object, especially if we detect that object a little late in the game. And the Starship would be capable of deploying either a vast laser array or a whole bunch of kinetic projectors or gravity tractors. You notice I haven't mentioned nuclear weapons. That certainly is the last resort that we would want to turn towards when it comes to asteroid deflection, because of the unpredictability of what such a blast would do to an incoming asteroid. Probably make the problem worse. In any event, the Starship could solve all of the problems that we've faced in terms of defending this planet from incoming asteroids simply because of its cost per kilogram. Whether we use it once a day or 3 times a day, as Elon Musk has proposed, the Starship would be capable of deploying hundreds and hundreds of tons of equipment necessary to defend the planet in very short order. That is, assuming the human race is willing to put the investment necessary into defending this planet. And I'm showing you this chart again just to give you a very clear perspective on how many objects there are out there, including quite a few that we have yet to detect, that could create anything from a localized nuclear-sized explosion many times more powerful than Hiroshima to something that would create a worldwide cataclysm. And I'm going to combine this chart with a chart that many of you have seen many times before. The vast number of origami-type solar panels that can be deployed into low Earth orbit by one starship. And instead of a transmitter, in this case, we might have a laser array or something along those lines to deflect asteroids. One starship could deploy an enormous amount of solar panels to power a very, very potent laser. So the point I'm trying to make is things like this don't have to be inevitable events in our near future. We don't have to fear this kind of thing falling on one of our major populated areas in the future. Instead, we need to invest in detection and invest in protection for our planet. And yes, it will involve a substantial investment, but consider the investment that we, about a decade ago, put into bailing out the banking system. An insane amount of money was invested by the U.S. government in propping up not only large banks, but other large American corporations that were deemed, quote, too big to fail, unquote, for the sake of saving the economy during the Great Recession. Now, perhaps it did save the economy. I don't know. I'm not going to hazard a guess on that one. But to those who say that saving banks is more important than saving human civilization from a cataclysm like this in the future, well, I have only one thing to say in return. Oh, and by the way, this is also to prove that this is not stock footage. So, now that I've made sure that my channel lives up to its name and reputation, and also perhaps gets shut down in the future, I would like to welcome all of you to 2021 to say thank you for 40,000 subscribers. I cannot believe that this channel has grown so fast in just over 1 year. It continues to boggle my mind. Once again, thank you so much, and remember, until our governments and our civilization takes the necessary steps to defend our species from possible extinction, or at least a horrific cataclysm in the future from a source that we didn't even know existed until the 20th century, I urge all of you to stay angry about space.